Perimeter of a rectangle is 120 centimeters. How should its dimensions be chosen to gain the rectangle with the given perimeter and the greatest possible area? Now, how can we start a problem like this? Now, if you have a geometric problem in question, you first of all draw a sketch. So we are given a rectangle. Let's call the two dimensions A and B. Also, we know the perimeter of the rectangle. Let's denote that by capital K according to the Hungarian notation system. And also let's use the Hungarian notation for the area, the capital T. Now the perimeter is 120 centimeters, and we know the formula for this in the case of a rectangle is 2 times A plus B. That is 2A plus 2B. But now you're going to use it in this form, that's why I left it in the factorized form. What are we looking for? We are looking for the maximum possible, the greatest possible area that we can have in the case of these kinds of rectangles with the perimeter 120 centimeters. And here comes the AMGM theorem in the picture. The identity A plus B over 2 is greater than or equal to square root A times B. That is, the arithmetic mean is greater than or equal to the geometric mean of the same two numbers. Now we also have to say here that A and B are both positive values because this is a geometric problem and A and B are side length. Now let's do some changes. Let's apply some changes on this inequality to be able to see something we have been given in the expression itself. Let's raise to the power of 2. We can do that, as I have already said, because A and B are both positive values. So raising now to the power of 2, it's going to be an equivalent change. Now the left-hand side is going to be the square of the arithmetic mean of A and B, while the right-hand side, on the right-hand side, the square will cancel the square root. So you're left with A times B. Now, is this familiar to you? Yes, it is, because it is the area itself. So we can say that the area of the rectangle is less than or equal to A plus B over 2 to the power of 2. Now, what is A plus B over 2 to the power of 2? Now, let's return to what is given, the perimeter of the rectangle. 2 times A plus B equals 120. So if you divide the two sides by 2, you get A plus B, and that equals 60. Now, A plus B appears in the formula, so we can replace A plus B by the value given, that is 60. Now, what is the greatest possible value T can take, so the area can take? Now, as you can see in the inequality, T is less than or equal to 60 over 2 to the power of 2. So if you work at the left-hand side, which is 900, you will have the inequality T is less than or equal to 900. That is, the area of the rectangle with the given perimeter, 120 centimeter, cannot exceed 900. It can be less than 900, but it cannot exceed it according to the inequality. So what we can conclude here and what we gained here is the maximum value for T. So we can now give an answer and say when we have the maximum area, the greatest possible area of the rectangle with a perimeter of 120 centimeters is 900 square centimeters. Now, when do we have this area? We can draw plenty of rectangles with the same perimeter, with different dimensions, of course. And because of the different dimensions, the areas are going to differ in size. Now, which one out of all of these possible rectangles is going to be or going to have the greatest area? To be able to give an answer, just let's return to the AMGM theorem for 1 second and check when the arithmetic mean is equal to the geometric mean. Now these two sides are equal if you choose the same values for A and B. So if A is equal to B, because see on the left hand side, A plus A over 2 would give us A, as well as square root A times A would give us A. So the two sides are equal if and only if A equals B, and that's true for the AMGM inequality. Now in this particular exercise, just remember the maximum area is 900, and we can say that this T is equal to 900 if and only if A is equal to B, that is the two dimensions are the same. So when we have, instead of A times B, A times A, that is A squared, so the area of a square. So then A has to be equal to 30 centimeters. So if you would like to extend your answer, you can say that the greatest possible area is gained if we have the square with sides 30 centimeters.